the difference between independent, dependent, and control. What I want to do now is show you how independent and dependent variables will decide on what your graph looks like. So what I have here is some mock data. It's about candy melting in the sun. So here's my little sun and here's my candy. And as the candy melts, it changes in surface area. As it gets larger and larger, we're assuming it's going to melt more and more, or it's melted more and more. So what I have is I have time in seconds. Every 10 seconds I check to see what the surface area was, and I measured it. And as it goes along, and as time goes along, the surface area actually changes and increases. So now I need to figure out which one is the independent variable and which one's the dependent variable. Remember that the dependent variable depends on the independent variable. Okay, the dependent depends on the independent variable. So now I have to figure out which of the two is independent, which one's dependent. Well, the surface area changes as time changes. So if the surface area was to change and that was the independent variable, then that means that the time depends on the surface area. So as the surface area increases, this is what the time has to be. Well, that's not really true, because if you think about it, if the surface area here, it goes from 3 to 6.9, that means that the candy became less viscous in this experiment, and then the time was 100 seconds. But I could squish the candy just as easily and make it 6.9 centimeters squared without it being 100 seconds. So the surface area isn't going to make the time change. Time doesn't really change based on surface area. I can't change time. I can't go forward or backwards whenever I want to. I can't make it speed up or slow down. So I don't think surface area is the independent variable. But time, however, is slowly ticking by, and as it goes by, the surface area is changing based on the time. The amount of time it's out in the sun changes what the surface area of the candy is going to be. So in this experiment, time is the independent variable. And I'll give you a hint. Almost all of the time is the independent variable. Because again, it's the one that we can't really change going forward or backwards. We just have to let time elapse. And as it does, it usually changes whatever it is that we're looking at. In this case, the surface area of the candy that's in the hot sun over here. So that means that on the x-axis, we have time, and on the y-axis, we have surface area. So now I want to make a little graph. So again, this is Excel. So if you look up here, you have home, layout, tables, charts. Charts is where I want to go. So the first thing I need to do is I need to highlight my data. Your x-axis should always be the one furthest to the left, the column furthest to the left, and then your y-axis should be the one to the right. You're going to go over here to scatter, and you're going to have marked scatter. So then it comes up like this. So now I need to deal with the layout of the chart. So I'm going to try and make this a little bigger. There we go. Oops. It's just making it. There we go. So here's my graph. So now I'm going to go to chart layout. And that will allow me to add titles, axes, etc., legends, whatnot. So I'm going to go to chart title, and I'm going to have a title above the graph. And the chart title is Candy Melting in the Sun. And then I'm going to go over here to axes, and my horizontal axis, I want below, with my horizontal title, I want below. And this is time in seconds. And then my vertical axis, I want it rotated. And then I put in here. And this is my surface area in centimeters squared. And then over here in the legend, you can have the legend just the way it is. You can come in here and change the I'm going to change it from series 1 to say something else, although it doesn't have to. Oh, I got rid of it. Because there's only one trial, so we don't really need it. But you could have more, if you had more than one trial, you would have to have trial 1, trial 2, etc. So now that I have my labels and I have my points, now I can add grid lines if I'd like to. I can have vertical and horizontal grid lines. Those are the major grid lines. You can have major grid lines this way as well. That's pretty helpful. The axes, again, are all set up just fine. You have your default axes, and you can change it to the thousands or the billions, etc. But now we want to look at the trend line. Now, in this case, we're looking for, most of the time, we're looking for a linear trend line. I know this kind of looks exponential, maybe a little bit, but it's not really. Again, this is fake data, so I don't really know what the trend should be, but 9 times out of 10, we're looking at a linear trend line unless I tell you otherwise. So I'm going to put in a linear trend line, and there it is right here. And that helps you to decide what the what your average basically should be. Okay? And you can actually extend this out if you wanted to make predictions about what could possibly be happening at 120 seconds, etc. So you can also make a y equals mx plus b equation for this trend line as well if you wanted to, using a set of data points that it goes through. If I use this data point and that one, I could actually figure out which one had what the trend line was, what the slope was of the trend line, and then what the y-intercept was. I can just figure out from just using the graph. But otherwise, that's basically what I need. I need a title, I need grid lines, I need axes labeled, I need the right increments heading along the side. This makes it really easy to do so. And then you can simply print this out with the trend line there as well. We'll talk about error bars at a later date.